Hello, students. Welcome to Parallel Lines and Triangles.
That sounds fun. Good day, humans.
Ooh, we've got to make some definitions of things. I think this would be something that'd be great for them to do for themselves.
That does sound like a good thing. Is that why it's called an activator on the slide?
I think so.
So they should do that. And if they can't do that, should they ask us?
They should.
Okay, so we should keep going.
Oh man, so this is something else that is a do on your own thing. This is a really cool thing that's worth doing, and you should definitely do this on your own as well. And just to kind of see what happens, and do that before you continue this video. All right. Hopefully by cutting up the triangle, you noticed something kind of cool. I have to press the edit button now. We were just complaining about Jamboard changed things, and that's one of the things that changed.
How dare they?
And you should end up with something that looks a bit like this with your three corners of your triangle. And notice that when you put all three of them together, it makes something that you should be really familiar with, which is a line that's composed of three angles altogether. Not a linear pair, but maybe we'd call that a linear triple.
I don't know that we have a name for that.
No, I don't think
So
so
are
either.
those the cutout corners of the triangle that they then arrange to be all connected? Is that what the little squigglies are?
That is correct. I'm an excellent artist.
Are they bad cutters? Is that
I'm assuming so, yes. Or
okay.
although to be fair, whenever I do this, I don't cut the corners because then I can't tell what the original corner was.
You just rip them off?
So I just rip them off, and that's easier.
Got it. There's a lot of black space here. So through a point to a given line. Well, that looks like they have parallel lines, right?
It does.
There's a point floating up here. So I want to see what's under this one.
You do you.
Now I can see it. Okay. Through a point not on a line, there is one and only one line parallel to the given line. So is that saying if we have this random point, so if I have a line, I'm going to use that black thing I just snagged. Nope, I threw it in the trash.
Well done.
If I have a line and I have a random point floating above it, which allegedly this will show up on your screen also, then I can only put one line through that point that's also parallel to our given line. That's what it's saying.
Oh, it's starting.
Okay.
I guess you only
That's
drew.
exciting.
There we go.
There's more to my drawing. It just hasn't shown up.
Yeah.
So that was my initial line, and then I drew a point above it, and then we're saying if we want parallel, if we one.
Because even if I'm a tiny bit off, it's going to end up like intersecting the line that we drew first and will not be parallel. So we have to be really precise for that, and there can only be one of those.
Like the Highlander. There can be only
That's
one.
it.
What's under this other thing? There's exactly one line through P parallel to L. Isn't that what we just said? Yes. Okay. Sweet.
Oh, that's just describing based on the letters they use in the diagram. Okay. I was confused. I was trying to figure out if that was like a way of rearranging that, but no.
So sum of the measures of the angles of a triangle is 180 degrees, which is what Mr. Carlson was getting at. The proof requires an auxiliary line. That is a line you add. That sounds fancy, but it's not really that fancy. If we go to the next page, we'll talk about it for you.
Oh, look, so there's a red line. That's not part of the triangle originally.
Yeah, so all they're saying is we have to add this extra line in. So in the past, I have done such things as just drawn a triangle and asked them to try to prove this. And if they needed a hint, maybe I would draw that line in. So what we're trying to get to, again, we're not going proof heavy here, is we would like to show that A, 2, and C make 180. Well, pretty quickly, we can see that 1, 2, and 3 make 180. 1, I should put measure in front of that, huh? Measure of 1, measure of 2, and measure of 3 is 180.
I'm really uncomfortable with this diagram right now.
Why?
because we've drawn an auxiliary line, but we haven't indicated anything about this.
Oh, that is fair. I assumed that there were arrows on it. I think that's a fair comment. These lines have to be parallel in order for this to work.
So we have to not just draw a random line through the top of this triangle. We have to draw a really specific line, and that is the one parallel line through that point. Which
is,
to be honest, that's the only reason why they mentioned that.
Right. That's why they mentioned, I think, on the previous page. So we've got these parallel lines. And with parallel lines, we have angle pair names. So that was part of that activator thing at the beginning, where we had alternate interior angles, same side interior angles, corresponding angles, and alternate exterior angles. And in this case, we care about alternate interior angles because if we consider, let me get rid of my blue thing. If we consider angle 1 and angle A, we can say those are the same because of alternate interior. And then if we consider 3 and C, those are also the same. Whoa, Mr. Carlson, what is going on here?
I was making a sticky note to hide your stuff that you moved off the page. Oh man, now I'm making a mess.
What did I move off the page?
The triangle, so you can only see one at a time.
Oh, I see what you're saying. I got really confused because you just zoomed in on yours and it didn't change my picture. So in what
wow.
Because if you do this on your iPad, it zooms in, but it's fine. So what Mr. Carlson did is he made it so that it's clear that we're talking about angle 1, and now I don't know what's going on. Oh, angle 1 and angle A.
I thought you had moved it.
No, you did it.
Fascinating.
You zoomed.
Oh man.
Now you're going to the next page. What is going on, Mr. Carlson?
I don't know anymore.
So we've got angle 1 and angle A are congruent by alternate interior angles, angle 3 and angle C. So what that means is I could get rid of angle 3 and replace with angle C. Mr. Carlson's just going to do what Mr. Carlson does over here, and nobody knows what's going on. And then I can replace angle 1 with angle A. And I still have angle 2, so I didn't touch that one. Oh, look, I did it.
Oh,
that's all it is.
So because those angles are congruent by alternate interior angles, we can swap them out because something being congruent means that their measures are equal. And therefore we can just plug them into that equation and get this cool thing. What is this cool thing? What does this do for us?
It tells us that angle A, angle 2, and angle C add up to 180.
Oh, and those are the 3 angles in this triangle.
Does that work for any triangle?
I think it has to, because we didn't use any specific numbers for this triangle.
Wow.
Cool.
It's like magic. This is like the written out formal proof. So if you want a more coherent one than what Mr. Carlson and I just did, feel free to read this and pause the video. But we're going to keep going. Ooh, what are the values of X and Y? This is scary.
Part of it's scary just because it's a mess of a diagram.
I made it smaller.
Thank you. That doesn't help.
Well, I'm gonna do 2 different pictures.
Oh, nice. Can I do the other picture while you do that picture?
Yeah. So ABD, I'm calling 59, X, and 43. We just figured out that the angles of a triangle add up to 180. So that means 43 plus 59 plus X equals 180.
Okay.
If we then solve for X, let's see, 43 and 59 is 90, 102. If I subtract 102 from both sides, I get 78. So that means X is 78. And then I'll help you out because I don't want you to get scared. There's a relationship there between X and Y.
I'm going to get scared first because I'm going to do the same thing you did. Y plus Z plus 49 equals 180. And okay, I can move the number. So Y plus Z equals, and then 180 minus 50 is 130. So that's 131. But I can't go any further because I have 2 different variables there.
But that's why I gave you the hint. There's a relationship between X and Y.
And we know X. And since X plus Y equals 180 and 78 is X, we can figure out that Y is really 102, just because that's what we got for the last time.
Wait, that's the number I subtracted over here.
It is. That's interesting.
Do you think that's going to show up at some point?
Probably.
Oh, okay.
So 102 plus Z is 131. That means that Z has to be 29. I like that we're not asked to find Z in the question.
Yeah, that's a little weird. I'm going
Whatever.
to add that. X, Y, and Z. There we go. It said it. It fixed it.
Thank you. Cool. Oh, an
Wow.
exterior angle.
I'm so prescient. I didn't even know this was coming. This is exciting.
I didn't know this was coming in this one either. I thought this was later, but that's fine. So this is a new thing for us in terms of the language here. When we're talking about an exterior angle, we're talking about extending one of the sides of our polygon, and the angle it forms with the next side is that exterior angle. These are somewhat useful because we can find some cool relationships with them. And then here we're talking about remote interior angles. So that's like not the one right next to it, which would make that a linear pair. That's probably an important relationship, but rather the ones that are far away, like they're remote, like not going to school currently because they're remote. See, I made this relevant to our COVID times.
You did. So I copied the picture from the previous page.
I
So
like it.
are we saying that Y is an exterior angle and the 59 and 43 are remote interior angles?
We are.
Did we just figure out a relationship between Y, 59, and 43?
I think we did, but let me see if I'm figuring out the same thing that you are.
Okay.
So when you added these two together, you got 90, 102. Like what I did there, I used your own words.
That's how I added.
I know. And when then I solved for Y a few minutes later, we also got 102.
Hmm.
So if we're thinking about that, those look like they're the same number.
Is
And
that like congruent supplements thing that we mentioned that one time?
technically, no.
But kind of, sort of?
Kind of, sort of.
Okay.
Because I know that X plus whatever Y is has to add up to 180 because that's a linear pair. I also
Is
know
that why
that
you put dots there to sort of what we're talking about?
I did. I also
Okay.
know that X plus the other two parts of this triangle must add up to 180 because this is a triangle. We know that triangles add up to 180. And usually that's like the one thing that students remember from triangles in middle school. So hopefully now that we've reviewed that, you really remember it. So if these two add up to 180 and then the same thing and the other two add up to 180, that does sound a lot like that congruent supplements thing. Cool.
Got it.
Oh, look, this is the same thing that we were just talking about and kind of discovered. And I bet that they're going to ask, oh, I like that you crossed out the thing I was about to ask about. This is what we were just saying, that the exterior angle is equal to the two, again, what they call the remote interior angles added together.
For remote, you could also say non-adjacent, right?
Yeah. This is also like, in all honesty, I don't really see the use of this theorem
Because you
because,
can just use the 180 thing.
yeah, and at most you save yourself one step.
Right.
So it's a cool observation. It's not an especially useful thing or worth trying to memorize
Got it.
if you want to do that type of thing.
So let's do this in two different ways then.
Ooh, which way do you want to do it?
Well, you've been talking about the exterior angle thing, so why don't you do the exterior
Okay.
angle thing, and I'll do the triangle thing. So you go first.
So I know that the exterior angle, that's this guy here. I'm going to make that the measure because I'm going to use numbers, is equal to the sum of the two remote interior angles. I think that's really my issue with this, is that language is super clunky. So that tells me that the measure of angle 1 is 98 degrees, not just the 90s band anymore.
They don't know that anymore.
I know.
So what I could do is I could say, well, I know that 80 plus 18 plus whatever that missing angle is has to be 180.
Mhm.
So that's 98, as you said. Subtract the 98 from both sides, and I'll get 100 No, like it's
No.
82. I forgot how to subtract. I got stuck with the 102 from the previous page.
I
82.
love it.
So this is 82. And then I know that this is a linear pair.
Mm.
So 180 minus 82 is the 98 degrees that you found earlier, and that's angle 1.
What I like about the way that you did that is that uses stuff that students tend to know better, which is that triangles add up to 180. And that makes that a lot easier to kind of work from.
I agree. So if you use the exterior angle thing, cool. If you don't, that's okay.
Yep.
Not gonna hurt you.
All right, here's another one of these. I think this might be a good one for them to do on their own.
I agree.
This might be another good one to do on their own.
I think we need to give them a picture. So two angles
That's
of a
fair.
triangle measure 53. So if I draw some sort of triangle, make this one 53, and I don't know, this one 53.
Sure.
What is the measure of each exterior and exterior angle at each vertex? So what they're asking you to find is every exterior angle, and it doesn't matter which, like you could have drawn it the way I did there, or you could have drawn this one. Those angles will have the same measure, so it doesn't matter which one we're talking about.
So we're looking for this angle, and this angle.
Yes.
Cool.
And I think they can probably figure those out. So they should pause the video and do that, and then we'll quick like a bunny write down what the answers are.
It's true. Pause.
Okay, I'm ready. So over here is 106.
Nice. Over here is 127. And
But this
over
is
here,
127 also.
you beat me to it.
Ah.
We are quick like a bunny with that.
And
you can ignore that.